Okay, welcome to the periodic table. So remember how we've discussed and how we've used this already in class, or how you've already used it in your online studies. But the periodic table is what we live life by in chemistry. If you don't have your periodic table and you don't have it with you for a test or for a project or for an experiment, and that be whether you're a student or an actual professor or a chemist themselves, you are probably going to miss something. It's also good to know where everything is and know the numbers to these different symbols, so that way you can actually use it properly. So you don't go through the alphabet every single time that you have to figure out which next letter comes next. And if you do, you're still singing the song, which is actually telling you about what your alphabet is. So in the periodic table, we use this because it shows how our elements are arranged according to repeated change in properties. So this means the properties that they exhibit. This means the number of protons they have, how heavy they are, different properties that we see throughout the periodic table. So originally it was developed by Dmitry Mendeleev. Mendeleev is a fantastic man who is from the Germanic countries over in Western Russia area, Eastern Europe area. He arranged the elements in order of increasing atomic mass. So remember, the mass number is the one that doesn't look as pretty. It's all the isotopes that's averaged together. So now we actually do it by atomic number, so the number of protons that we see in our elements, because that's much easier to view. But atomic mass works too, because if you look at it, there aren't any atomic masses that are less than the one before. So they're always going to increase as we go. So his increasing atomic masses actually worked. He also discovered that chemical properties tend to repeat as we go across. So he would get to a certain point and say, hey, this makes sense that it works here in this group. Let's move to the next one. It also arranges to the electronic configuration of elements. So when we talk about electronic configuration, we're talking about where they are found mostly in their ground state. So how close they are to the nucleus or how far away they are. So our modern one was made by Henry Moseley. Elements are arranged by increasing atomic number. You can see how that's easier, and the similarity of properties exist. But Mendeleev was actually brilliant because he discovered that he knew that there was another element there, even if it hadn't been discovered yet. So he moved to the next one, knowing that that spot was going to be found someday. And so he used that before. But Henry was able to take discoveries that were being made and prove that they went in increasing atomic number. So periodic law is when elements are arranged in increasing atomic number. So there is repeating pattern in their physical and chemical properties, and that's why we see the different colors of our periodic table. They show the chemical and physical properties of the different groups of elements. So it allows us to study elements in groups rather than individually. It allows us to predict characteristics of elements that have yet to be discovered. So all these, when you look at the elements that are man-made or unknown chemical properties, we know that they will exist at some point because we see that their properties are there. We can predict it based on what we've seen be repeated. And it is an easy reference. So for instance, if instead of me having to memorize all of the atomic numbers or all of the atomic masses or mass numbers of these elements, I have a nice little reference to go back to, and I can look at it and use it to pass any chemistry test or do any chemistry experiment that's possible. It also allows you to predict which elements will bond with each other in chemical reactions. So this includes 3 different types that we look at. So we have nonmetals, metals, and metalloids. So metals are about 80% of our periodic table. They are good conductors of heat and electricity. They have luster, solids at room temperature, except for mercury. Mercury is the only liquid metal. Ductile, so they can be made into wire or hammered into sheets. That is a characteristic of a metal. So I'm pretty sure that you've looked at metals before and understood what a metal is. And even though you may have not worked with tungsten very often, or you haven't worked with zinc very much, you know what they are, or gallium, but you know their properties relatively based on the ones around them that you've seen before. So nonmetals are this nice little blue area. So they're mostly gases, except for sulfur and phosphorus. They are poor conductors of heat and electricity, except for carbon, because you can see carbon is actually closer in relation to our metalloids and metals than any other one. And you can also see that all of these others are pretty much gases all the time. And you know, how do we know that carbon is mostly gas at room temperature? Because carbon dioxide. We look at carbon dioxide, we look at carbon. Carbon is mostly in the air. Carbon monoxide, all these different carbons that are gases, when they connect together, now we have different carbons that are solid and really good conductors of carbon fibers. So when you see light bulbs, those are carbon filaments that actually allow us to see. So that's how carbon works. And metalloids are the next stair step. So this is this area. So the nice pink area. They behave like a metal or a non-metal depending on which state they are in. So if it is solid, it may act more like a metal, and if it's a liquid or a gas, it may act more like a non-metal. So it just depends on their different characteristics.